So there are lots to talk about limits. So this lesson will be divided into two sections. And for the first lesson, we'll talk about the ways to find the limit. Alright, so in order to start this, we have to know what limit means. So the definition of limit refers to the value that a function or sequence approaches as the input or index approaches to some value. Or, for example, let's talk about the geometric sequences. Let's say for an infinite geometric series with the r, which is the common ratio, greater than 1, it eventually converges to a certain value, and that value could be considered a limit of a geometric sequence, since it is not the value but is approaching there, meaning it's reaching closer and closer as x approaches to some value. So this is actually a very fundamental concept, once again, for calculus, since it is like the fundamental way to find a derivative function. So, as I said, if, like in a geometric sequence, if a series converges to a number L, we say the limit is L as x approaches infinity, or to a certain value. And it could be expressed as the following, which is limit of f of x as x approaches to a, which is a certain value, it could be infinity, results in the limit value of L. And now we will talk about the way how we can find limits. There are actually a lot of ways, but I just categorized into a few of them. And the first one is through the method of substitution, which is like substituting in the value as the input is approaching to the input of the function. So here's an example where p of x is equal to 3x squared plus 5x minus 9. And we have to calculate the limit of p of x as x approaches negative 2. And the way how we can find limit through substitution for this example is by substituting negative 2 into x. Then 3x squared plus 5x minus 9 would equal 3 times negative 2 to the power of 2 plus 5 times negative 2 minus 9, which is 12 minus 10 minus 9, which results in negative 7. As a result, the limit of 3x squared plus 5x minus 9 as x approaches negative 2 is equal to negative 7. Besides substitution, you can either find it algebraically or graphically. So let's talk about the algebraic one first. Here's the function f of x equals negative 1 half to the power of x plus 2. And in order to find the limit as x approaches to infinity, all you have to do is basically substitute in the value, which kind of involves substitution. And you see, if infinity is substituted here, then this eventually would approach 0, meaning the limit value would be 2. And you could see this graphically. Here's the graphical representation of the following function. So as input is heading towards infinity, the function is actually approaching to a value. And if you constantly extend this graph towards infinity of the input, it eventually approaches x. And this kind of relates with the use of tables, which is finding the limit numerically. This is basically a table with the input of the same function, y equals half to the power of square plus 2. And as you see, as x approaches to a great value or to a greater value, the value of the function approaches to 2, meaning the limit value of this function as x approaches to infinity equals 2. And here are some practice questions that I would like to share. Here's the first question. The function, which is f of x, is equal to x cubed plus 2x squared minus 5x minus 6. And now you have to find the limit of f of x as x approaches 2, as x approaches negative 3, and as x approaches infinity. Here's the second question, where it is actually a rational function where it's 2 over x plus 3 minus 4, and you have to find the limit for as x approaches to the aforementioned value. The answer sheet and the solution will be posted at the comments, so keep in mind. Anyways, this is Daniel, and thank you for your time.